Alright, I wanted to cover a few things about the periodic table to hopefully make it a little easier to remember. So basically, if you're reading from left to right in a sentence, you put a period at the end. So that's one way to remember that the left to right going across are periods, because you put a period in a sentence. Obviously, you don't write your sentences up and down. And then the up and down columns are considered groups or families. As you look at the different families or groups, the main two you have to remember are the first two and the last two. And then all the other ones in between are named by the top element. So this one would be boron family, carbon family, nitrogen family, oxygen family. So these are very easy to remember, especially since you're going to have the periodic table. So it's only the first two and the last two. So an easy way to remember it is the first two are at the beginning of the alphabet you could think of, and they both start with A. So alkali metals, and then the next one gets a little more complex and a little longer in its name, and it's alkaline earth. So you got alkali metals, alkaline earth. Then, like I said, the only other two you need to know are the last two. So remember, this last section is the perfect one. They all have their valence electrons filled. So these are called noble gases. I think in the book it talked about how they don't like to bond with anything, that they're very content with their full valence shell. So they're kind of like snobs, like royalty snobs, where they won't interact with others. And so then the only other one you need to know are the halogens. So noble gases, halogens. And then, like I said, as long as you know the first two columns, which they start with an A at the beginning of the alphabet, alkali, and then it gets a little more complex, alkaline earth. These in the middle here are just named by the top element with the word family, and then you got halogens and noble gases. So then we're going to look at each one just a little more detailed for a minute. So as you look at so actually, before we go into each group, this is the stair step. Everything to the left of the stair step, including these down here, everything is considered a metal. Then you've got the four sitting on the stair step, and then you climb back up two. Those are called the metalloids, and then you've got the nonmetals to the right. If you have trouble remembering which is which, a quick and easy way to look at it is you can look over here and say, okay, hopefully everybody knows what oxygen is, helium, and we can say, okay, I know those are gases for sure. So then you can say, okay, yes, that's right, these are the nonmetals. And then if you look over here, you've got aluminum, silver, gold, nickel, platinum. So you can recognize some of these and go, okay, these are for sure metals. So like I said, worst case, if you forget which side is metals and which side is non-metals, you can always look at a few of the elements to remind you. So now we're going to look at each group individually. So the first group we're going to look at is the alkali metals, which is this first column. And remember, the column, if you look up here, the 1A tells you that there's one valence electron. So remember, all atoms or elements want to have a full valence shell. That's their goal. So because these all have one, they actually are, if they can lose that one, then they'll be back down to the full valence. So these are very reactive. They're one electron away from having a full shell by getting rid of that one. And so they are actually never found as pure minerals in nature. So they're always bonded with something else. So, the next one is the alkali earth. These are reactive as well, but obviously not nearly as reactive. They have 2 valence electrons, so they're a little bit further away. They are used in alloys. So remember, an alloy is when you take 2 or more metals and basically melt them and mix them together. Not to be confused with metalloids. Remember, metalloids are these dark shaded elements over here. So the next group are transition metals, which are basically all of these in the drop down area, and that includes these down here. All of these have between 1 and 2 valence electrons. Then, like I said, the next groups, you just look at the top element and you name it by its name. So this is boron family. So all of these are boron family. Notice in the boron family you have a metalloid, and then the rest of them are metals. Obviously, in the alkali and alkaline earth, they're all that same group. But in the boron, they're all metals. But in the boron family, you've got a metalloid and metals. In the carbon family, you have a nonmetal, 2 metalloids, and 3 nonmetals. Nitrogen, obviously, you can pick up 2, 2, and 2. And then in the oxygen family, you've got 3 nonmetals, a metalloid, and 2 metals. Then the halogens, once again, the halogens are very reactive. They have 7 valence electrons, and all they need is 1 more. Now remember, helium, technically, even though it's in the 8th column, helium only has 2 valence electrons, and that makes it full because the first energy level only holds 2 electrons. So I know we constantly say this column holds 8, but remember, helium's that exception and it holds 2. So like I said, going back to the halogens, they are very reactive. They've got 1 electron away from having a full valence. If you recall, remember that diatomic, I said it starts with the 7th element and it makes the number 7, and there's 7 of them counting hydrogen over here. So 1, 2, 3, 4, 5, 6, 7. Those are all the diatomic elements, and notice that they're halogens. That's how reactive the halogens are, is they're never found alone because they're so reactive that they'll bond with each other to make them, I guess, steadier. And then the noble gases is the last family, and they are very stable. They have a complete valence shell, and you pretty much always find them alone, unreacted with anything else. So the only other thing I wanted to kind of point out, and I had this in the notes, was as you look at atomic radius, so remember basically the radius of the atom, the one way to remember it is this left corner is the biggest. So as long as you're traveling to the left, you know it's getting bigger, or if you're traveling down, it's getting bigger. So you'll have questions like like you saw in Quizlet, or I mean not Quizlet, but Kahoot, put them in size order of increasing order. So you always want to make sure that you're heading to the left as it increases and you're heading down as it increases. And then same thing, conductivity is the same. It's the biggest in this corner, so you know that it's going to get bigger to the left and traveling down. Okay, that's all I got for you.